Our topic is automated heart diseases classification. Project focus on using deep learning to improve heart diseases detection. Introduction: heart diseases causes millions of deaths yearly. ECG records electrical activity of the heart. Manual analysis also there, and AI-based automations used for detecting and abnormalities, whereas the normal or maybe an abnormal can be resulted. Need for study, increasing number of cardiac patients, shortage of expert, need for fast and accurate diagnosis, reducing workload on healthcare professions. This all need for study. Objective: develop automated classification system. These are using for CNN extraction and for improve accuracy and speed. Problem statement: manual ECG interruption varies by expert, difficult to detect abnormal. Time delay in emergency, need reliable automated system. These are the manual interruption varies by the expert. Methodology: data collection, signal pre-processing, further extraction, CNN model, classification and their output, where the extraction will continue to CNN model. It will flows to the input and classify often and provide output. Flowchart: input, noise, segmentation, extraction, CNN and their production. ECG signal: P wave, QRS complex, T wave important for detecting abnormal. Atrial ventricular recovery phase. For this ECG signal that flows in this three complex: pre-processing, noise removal using filters of signal, segmentations of ECG bits, improves signal quality, and extraction, exact important ECG time domain, helps CNN learn patterns and effectively. These are the extraction we used in this ECG features and their time and frequency. Architecture: convolution layer RELU, pulling fully connected layer, output layer, which is extracts, adds, reduces, classifications and their final. Training process: data set split into training and testing, model trained using and optimizer, loss function minimalized. This all can be accuracy improved. Overall, this split results accuracy achieved 92-94, low error rate, fast prediction time and effective classification. These are the results we get. Application: hospitals and clinics, remote health monitoring, wearable health devices, emergency diagnosis system. Advantages: high accuracy, automated extraction, fast processing, reduces human error. These are the possibilities. Limitations: requires a large data set, high computational cost, dependent on data. Conclusion: CNN improves ECG classification, helps early detections. Scope: real-time implementation, convolution layer, pulling layer, fully connected layer. Activation functions: filters and downsampling, RLU, rectified linear unit and introducts non-linear unit. This is where the actual classification happens in this layer. One of the most widely used in following advantages: easy to acquire, produces real-time monitoring, baseline draft, power line interference. ECG signal often contain this type of noises: baseline and power line interference and draft, which is a 4 layers: image enhancement, segmentation, extraction, classification, improves image, divides the image, extends the importance of characteristics, peak amplitude and the normal abnormal characteristics, and the automated classifications of heart disease. CNN algorithm diagram. Workflow of CNN: data collection, pre-processing, CNN model, training, evolution, access of performance using like accuracy sensitivity segment of ECG signal gathered in data sets. Example, MIT BH trained the CNN using ECG data, whereas the 4, which is model accuracy comparisons, low high, the curve, the accuracy, loss, accuracy, confusion, model accuracy, 97 point accuracy, and 88% CNN, indicating the superior classification. The matrix shows 120 true positives. The both training and validation accuracy improve with high values, which confirms the model's learning in this accuracy with stability, and the validation loss decreases steadily, showing effective learning. Automated ECG analysis, noise reduction, image based processing, further extraction, accurate classification, the use of CNN. This may be related with a high classification accuracy. Features such as waveform, patterns, and intervals were extracted efficiently. ECG signals were successfully converted into image format, enabling advanced analysis. Whereas the data dependency also, the requirements and their limited data set size, generalization issues, or this type of 4 has some limitation despite of advantages, requires high quality ECG data sets. Whereas a real-time monitoring system integration, use of advanced deep learning models, cloud-based implementations also there, enable remote access and storage large database and improve scalability and requirement RNN and LSTM, long short-term and recurrent neural networks. The more advanced models in deep learning models can be used to improve accuracy and their performance. Cloud-based implementation enable storage and improve their scalability database. The project achieved its conclusions objective successful. The system is efficient, accurate, and reliable. It provides a strong base for future advantages. The power of combining signal pre-processing, image processing, and deep learning, and then the code works step by step. The program begins by clearing the workspace and closing all figures, resetting and command window, which is the first step 1. The system allows the user select an ECG image file using common image PNG, JPG, JPEG. User does not select any file. The program stops with an error message. Step 2. The input ECG image is displayed using a figure window. Can be used visually confirm the selected. Step 3. The program performs extraction, basic and calculated mean standard deviation of the image. Step 4. The program uses rule based classification, normal, and each condition corresponds specific range. 5. The results displayed ECG image is shown again. All 4 possible disease name listed in the image. It makes easily to visually identify the classification result. ECG image using image processing, rule based decision in MATLAB. A ECG signal analysis or machine learning in this techniques. Whereas the output, which has a 4 condition, while we extracted input and an image, whereas a file PNG, JPG or JPEG, the output will be shown in 5 range, which is the categories normal, arrhythmia, myocardial infarction, diacardia. Each condition corresponds a specific range of entropy values, which is marked in red. The program uses a rule-based classification, which I mentioned the 5 and 4 categories in this specific range. and ECG parameters like heart rate or RR. Thank you.